Good afternoon to all, and welcome you all for the 29th lecture on basic circuit theory. To summarize the last class, we discussed the variation of impedance, okay, with respect to frequency. What is the variation? X-axis, frequency in terms of hertz, and Y-axis, impedance, okay. So at resonance, you will get minimum frequency. At resonance, you will get minimum frequency. Okay. So at resonance, the frequency is given by R. So here, you got a curve like this. I don't want to repeat this. You know how you have got the curve like this, and why. Okay. And here, one interesting fact. Okay, if this range, when the frequency is less than resonant frequency, who is dominating? Anyone? XC is greater than XL, or XL is greater than XC. When frequency is less than resonant frequency, XC dominates. When frequency is greater than resonant frequency, XL dominates. So here this is called capacitive in nature. In this range, inductive in nature. Here it is pure resistive at resonant frequency. Now coming to variation of I, right? It's quite important. From Ohm's law, both I and R are inversely proportional. So here எப்படி இருக்கும் at resonance, here you will get maximum current because of minimum resistance. So if you will plot, you will get a curve like this. Okay, so at resonance, actually at resonance you are getting maximum current. Okay, and this formula is given by simply applied voltage divided by R. So now after that we discussed, and I have given the overview of variation of voltage. So here, since series circuit, you want to play with three voltages. Okay, take this is my frequency in terms of hertz, and here voltage in terms of volt, and let me assume this is my applied voltage Vs. The voltage drop across resistor almost equal to, okay, at resonant frequency. Now this is my the voltage drop across resistor. Take this is my resonant frequency. At resonant frequency, maximum voltage drop occurs, okay, across resistor. Now in this range, okay, in this range, here XC is greater than XL. So in this range, maximum voltage drop occurs across capacitor. So if you will plot it, suppose take here I am getting maximum voltage. So across capacitor, so this frequency is called FC. If you will plot, you will get a curve like this. Okay. Now similarly in this range, here you will get the maximum voltage drop occurs across inductor. That's how this is FL. So if you will plot the curve, you will get a curve like this. Okay. So here what is FC and what is FL? This is very important. FC, frequency at which maximum voltage across capacitor occurs. Okay, similarly FL, this is not lower frequency. Here L stands for inductor. So frequency at which maximum voltage, okay, across L occurs. Or voltage drop occurs, okay, across L. In any way you can write it. So here actually this derivation is quite interesting, but I don't want to derive, okay, this formula for you people. Straight away I want to give the final expression. You want to know what is the formula for FC, and you want to know what is the formula for FL. Okay, this derivation is not required for you people, and you want to know one expression, it is square root of 1 minus, I am playing with the RLC circuit, right? So here you will get R squared C divided by 2L. Okay, FC is given by the resonant frequency is multiplied by that factor. So it is FR minus R squared C divided by 2L, whereas FL is divided by, okay, FR divided by square root of the same factor. That's what, please remember this. Okay, then it's quite easy. So this formula is very, very important. There may be a chance for asking problems based on this formula. Okay, when maximum voltage drop occurs across inductor, when maximum voltage drop occurs across capacitor, then you want to know this formula. Okay, now based on this, take one problem, then you can understand. Take example 1 for today's class. Okay, take R equal to 10 ohm, L equal to 0.1 Henry, C equal to 50 micro, and applied voltage V 50 at an angle of 0 degree volt. You want to calculate three things. First one, resonance frequency. Second one, frequency FR, right? Sorry, not everything I want to enter into small letter. So voltage drop occurs across capacitor, frequency at which maximum voltage drop. Okay, you know one relation, FC definitely less than FR and FL definitely greater than FR. Okay, now I want to play with the numbers and I want to verify whether these conditions are satisfied or not. Okay, that's my thing. So now solution. Please take your calculator and please help me. தனியா தவிக்க விட்டுறாத. First one, to find resonance frequency, simple substitution, right? So you know FR resonance frequency, the formula 1 divided by 2 pi square root of LC. So 1 divided by 2 pi square root of, where L is 0.1 Henry and C is, you know, 50 micro. What is this value, anyone? Please help me. Second one, to find FC. FC, you know, this is FR times square root of 1 minus R squared C divided by 2L. And my final thing is, third one, to find FL, it is given by the same factor, this time FR divided by square root of 1 minus R squared. What is our resonance frequency? Where is my calculator?
71.2 hertz.
Thank you. So now this is 71.2 times square root of 1 minus R 10 squared 100 times C 50 micro divided by 2L 2 times 0.1. What is this value? And here this is 71.2 divided by square root of 1 minus 100 times 50 micro into 2 times 0.1. What about this value? Please let me know. One of you please find FC, another one please find FL, and let me know both the values. Particularly for FC, frequency at which maximum voltage occurs across capacitor. Definitely should be less than 71.2.
FC 70.3 hertz.
70.3 hertz. FL
72.13 hertz.
so it's satisfied. FC less than FR, right? Yeah, 70.3 is less than 71.2, and FL, that is 72.1, is greater than 71.2, right? That is satisfied. So got my point. So what's the next topic? We completed the variation of impedance, current, and voltage. Next, we want to discuss three interesting factors. First one is bandwidth. Communication point of view. Very, very important concept. Okay. Any idea what is bandwidth? In general, actually, it is width of a band, right? What do you mean by bandwidth? Width of a band. Right. So here the band, it is measured in terms of frequency. So what is this? Range of frequency, or singular range of frequency. Although certain range. Okay, so it is measured in terms of frequency signal. It may be signal or it may be system. Okay, so you want to measure the range of frequency. Now coming to RLC circuit, where you will measure the range of frequency in circuit response. You know what are all circuit response? It may be voltage or current, right? Once if you will find voltage and current, then you can find power, energy, and so on, right? So circuit response, general thing, as I told earlier, voltage or current, right? So either you can measure at voltage or either you can measure at current. And you know, here which one will you choose, voltage or current? Since here series circuit, who is same, voltage or current in series circuit? In series circuit,
Current
which
is
one is?
same, sir.
So current is same. So that's what I want to go with. Okay, the current, you know the variation of current, okay, with respect to frequency. Since series circuit, so I want to play with the current. In parallel, you will play with the voltage. That is the rule. So this is my, what is this? Frequency. This is I, right, in terms of ampere or milliampere. So now at resonant frequency, FR, okay, you will get maximum current I max. That formula, you know, V divided by R. Okay, this already you know. Now, how to measure bandwidth? Okay, where you will measure? Everyone knows Tamil, right? Everyone knows Tamil. Any other state people? I'm going to tell one statement in Tamil. அதனால தான் கேட்குறேன். தமிழ்ல நமக்கு ஒரு ஃபேவரேட்டட் ஒன்று இருக்குல்ல, ஒரு அடிமை கிடைச்சிட்டான் அப்படிங்கிறதுக்காக அவனை வந்து 100% யூஸ் பண்ணக்கூடாது. ஓகே, ஐ டோன்ட் வாண்ட் டு கண்டினியூ. ஸோ இதே மாதிரி தான் சிஸ்டம்லையும் நமக்கு ஒரு சிஸ்டம் இருக்கு அப்படிங்கிறதுக்காக சிஸ்டம் 100% யூஸ் பண்ணா என்ன ஆகும்? அந்த சிஸ்டமோட எஃபிஷியன்சி, வாட் வில் ஹேப்பன் டு த எஃபிஷியன்சி? மொபைல் ஃபோனே ஒரு நாளைக்கு 24 hours ஒர்க் பண்ணா, யூஸ் பண்ணேன்னா அதோட எஃபிஷியன்சி என்ன ஆகும்? லைஃப் டைம் வில் பி ரெடியூஸ்ட். ஓகே, பெர்ஃபார்மன்ஸ் வில் பி டீக்ரேடட். ஸோ ஆல்வேஸ் என்ன பண்ணுவாங்க அப்படின்னா, சர்க்யூட் பாயிண்ட் ஆஃப் வியூல இட் இஸ் வெரி இன்ட்ரெஸ்டிங் கான்செப்ட். யூ வாண்ட் டு யூஸ் ஒன்லி 70%. Okay, average, take any system or any signal. If you will use it for 70%, okay, ஒரு நாளைக்கு மொபைல் ஃபோனை மிஞ்சி மிஞ்சி போனா ஒரு 4 hours to 5 hours யூஸ் பண்ணலாம். ஓகே, you are all matured people, so I don't want to enter in that topic. So similarly here also you want to go for 70%, right? So here the maximum current is I max. 70% of I max you can go. So that is given by, this, you want to divide this I max by square root 2. It's very interesting concept actually. Take any voltage, any current, maximum voltage, maximum current, divide by square root 2. இந்த கான்செப்டுக்கு பேர் ஆக்சுவலா RMS. ஓகே, ரூட் மீன் ஸ்கொயர் வேல்யூ. ஆக்சுவலி 4th யூனிட்ல இதை பேசிட்டு தான் இங்க வந்திருக்கணும். பட் நம்ம ஸ்ட்ரெயிட் அவே ஸ்டார்டட் வித் 5th யூனிட். ஸோ டைம் பீயிங், டோன்ட் வரி அபவுட் திஸ். ஜஸ்ட் keep in your mind, you want to take 70 percentage. Why? Then only the efficiency will be high, lifetime, okay, will be high, the remaining things and all in practical. So why divide by square root 2? If you will divide by square root 2, what will happen? It's very interesting concept actually. What is 1 by square root 2? This is 1 by square root 2 of I max. Anyone? What is 1 by square root 2? Take your calculator. Let me know. It's quite
0.707, sir.
0.707 in terms of percentage.
70.7%.
So almost equal to 70 percentage. So that's why what you want to do to measure the bandwidth. Okay, this time actually this full scale வந்துட்டு ஒரு 100%னா 70% எங்க வரும்? அப்ராக்சிமேட்டா இங்க வரும்னு வச்சுக்கிட்டா. Okay, so now here what do you want to do? Draw a straight line. Okay, now this is my I max by square root 2. Why square root 2? 70%, right? So now where it cuts, okay, the curve at the very first time, this frequency is called lowest frequency, FL. This L is not inductor, lowest frequency. Where it cuts the next time, that frequency is called highest frequency. Now the difference between these two. Now this is the band. Now suddenly I was looking for a band, right? This is my band. Now how will you calculate this bandwidth? So this is the bandwidth. Okay, bandwidth which equals. How will you calculate the difference, right? So highest frequency minus lowest frequency. Okay, actually this is my bandwidth. Better. Actually this is my bandwidth. So here it is calculated bandwidth equals highest frequency minus lowest frequency. This is the formula to calculate bandwidth. Okay. So got the idea? What is bandwidth? Width of the band. So where you will fix the band or where you will get the band? Either you want to go with voltage or current. Since series circuit, I have gone with a current response. Okay, the variation of current with respect to frequency. In that, can you go with highest? Can you go with the maximum current? Yeah, it is not possible because you want to use 70%. Okay, அடிமை கிடைச்சா கூட 70% தான் யூஸ் பண்ணணும். That is the conclusion. Okay, so take 70% I max by square root 2. Now draw a straight line. Draw a straight line. Okay, where it cuts. Okay, the response, the curve at the very first time, that is your lowest frequency. Next time, it is your highest frequency. The difference will give you bandwidth. Actually, we are going to derive bandwidth. Okay, this FH minus FL. Very interesting formula. If you will derive the bandwidth, okay, in terms of hertz, right, then you will get R divided by 2 pi L. RLC circuit, so you will have R and L. So bandwidth in terms of hertz, this formula. Suppose bandwidth in terms of radian per second. What is the formula? Radian per second. You want to multiply with 2 pi. So 2 pi times R divided by 2 pi L will give you R by L radian per second. R by L, this is radian per second. So two formulas for bandwidth in terms of hertz, R divided by 2 pi L. In terms of hertz, R divided by 2 pi L. In terms of radian per second, simply R by L. Simply R by L. This one only actually we are going to derive. This derivation we want to derive. There is no other way. Even though you are mechanical, லாஸ்ட்ல ரெண்டு ஃபார்முலா சைட்வே கொடுத்தாலும் அந்த மாதிரி இங்கே கொடுக்க முடியாது. This you want to derive. It's quite interesting derivation. It's very simple. Okay, just we are going to play with differentiation. That's it. Okay. Now, shall I start? Now, so to derive bandwidth. Okay. Now listen. At FL, at lowest frequency. Or in general, this is my series RLC, right? Take on R, L, C, and applied some current. Sorry, applied some voltage VS. This is my R. Here the impedance offered JXL, this is minus JXC. Here XL equal to L omega, XC equal to minus, XC equal to 1 by C omega, that you know. Now what is the current formula, anyone? What is the current here? I equal to V by R, V divided by R is, all are counted in series. So this is R plus JXL minus JXC. This is V divided by R plus J times, already we derived this, but anyhow, XL minus XC. Okay, so now this is the I equal to V divided by R plus J XL minus XC. Okay, but at FL, what is my I? At FL, what is my I? It is I max by 2, right? Okay. But in general, what is my I? I V divided by R plus J XL minus XC. Okay. Now listen me carefully. Till now, any doubt? So at FL, can I start the derivation? Are you with me?
Yes,
At
sir.
FL, I equal to, I max by square root 2. Okay. So what is the formula for I? That formula, I equals V divided by R plus J XL minus XC equals. What is the formula for I max? What is the formula for I max? It is V by R. So can I write V divided by square root 2 times R? Okay. Now take the magnitude. So it becomes V squared. Since here I'm having, complex number. So I want to take the magnitude. It's become V squared, okay, divided by A plus JB. What's the magnitude? Square root of A squared plus B squared, where A equal to R squared plus XL minus XC the whole squared equals, here it is V squared divided by 2 times R squared. Okay, squaring both sides. Take the magnitude. First to do one thing. Take the magnitude alone. V divided by, then we will square. Otherwise you will confuse. So first take the magnitude. Taking magnitude. Okay, so V divided by A plus JB, square root of A square plus B square, where A is R, B is XL minus XC. Okay, so now squaring both sides. What is the squaring? So it becomes V squared divided by, here it is R squared plus XL minus XC the whole squared equals V squared divided by 2 times R squared. Okay, any doubt till now? I took the current at FL, that's it. So remaining simple mathematics. So now what will happen? V squared cancel. Therefore, what is remaining? R squared plus XL minus XC the whole squared equals 2 times R squared. Can I write? Bring this here, okay, and bring this one to here. Okay, then you will get R squared plus XL minus XC the whole squared equal to 2 R squared. So now, okay, bring this R squared, okay, to the right hand side. So you will get R squared equal to XL minus XC the whole square, right? Where XL equal to L omega, XC equal to 1 by C omega, but this is I took at FL, right? So omega becomes omega L. Okay, so this is my R squared. Now, okay, taking removing square, you want to take a square root. Therefore, This is plus or minus R, which equals, for frequency you want to consider only positive value here. So here there is no need of plus or minus. So plus or minus R equals L omega L minus 1 by C omega L. Okay. Take this is equation number 1. Any doubt till now? Okay. Now listen. At FL, who is dominating? At FL, at lowest frequency, XC dominates XL or XL dominates XC. XC is greater than XL or XL is greater than XC. Anyone?
XC is greater than XL.
XC is greater than XL. If XC is greater than XL, what will that for? This L omega L minus 1 by C omega L, is it equal to R or minus R?
Minus R.
Minus R. Why? Since XC is greater than XL. But here, this is XL minus XC. So obviously you will get minus R. Okay. Obviously you will get minus R. Similarly, at highest frequency, if you will derive, what you will get? This time, if you will do the same thing, so this time omega L becomes omega H, highest frequency. At highest frequency, is it minus R or plus R? At highest frequency FH, XL is greater than XC, therefore, XL minus XC, is it positive or negative? So this time it is positive, right? Take equation number 2 and equation number 3. Okay. So we found equation number 1. From that, at lowest frequency, it equals to minus R. So obviously, at highest frequency equals to R, right? Now take equation number 2. Take equation number 2. What it's minus R equals, take the LCM, so it becomes C omega L. This is L C omega L square minus 1. Okay. Now move this term, okay, to the left hand side. What you will get? Minus RC omega L equals LC omega L square minus 1. Now this can be written. Now move this term, okay, to the right hand side. You will get LC omega L square. This becomes plus RC omega L minus 1. Okay. You know this formula? X squared, okay, plus some constant AX plus some other constant B equals 0. What is the value for this X? X equal to quadratic equation. What is this? This formula can you remember? Minus B plus or minus. Okay. Actually here it is some constant B nu vechikalam. Some other constant C. Actually here it is A, right? But A should be always equal to 1. So this is minus B plus or minus B squared minus 4AC divided by 2A. Can you remember this? What is this equation? Anyone? Please help me.
Roots of quadratic equation.
Quadratic equation, right? So now, in order to get this format, okay, what you can do? What is the coefficient of omega L squared? Here unknown is X. Here unknown is omega L. Since I want to calculate omega L, so here the unknown is omega L. So omega L squared coefficient should be 1. As I told earlier, always this A should be 1. That's the best practice. So now divide the above equation by LC will give you omega L square plus RC divided by LC omega L minus 1 divided by LC equals 0. Right? Now this CC get cancelled. So straight away can I write R by L omega L. So here what is this? Therefore, A equals 1, B equals R by L, C equals minus 1 by LC. Okay. Therefore, what is my omega L? X equal to minus B minus R by L plus or minus square root of P squared, where P is R by L minus 4AC, 4 times A equal to 1, C equal to minus 1 by LC divided by 2A, where A equal to 1. Okay. So therefore, what is my omega L equals minus R by L plus or minus square root of R by L the whole square. This minus minus becomes plus 4 by LC divided by 2. Now I want to bring this, okay, this 2, this denominator to the numerator. So it can be written minus R by 2L, right? And it goes to R by L, it becomes minus R by 2L plus or minus. Now you want to move this 1 by 2 inside the square root square, it becomes actually 1 by 4. So can I write this is R by 2L the whole square plus 1 by 4, right? So 4 divided by 4 times LC. So here both 4 would get cancelled. So the above equation becomes minus R divided by 2L plus or minus square root of R by 2L the whole square plus 1 by LC. This is my omega L. Take equation number 4. This is the way to calculate omega L by using quadratic equation. Okay. Actually where I started from equation number 2. If I will choose equation number 3, what could be the value for omega h? Any idea? From equation 3, similarly, if we will derive omega h, what you will get? What is the difference in equation number 1, 2 and 3? Equation number 2 and 3, here it is minus r, here it is plus r. Okay, for minus r, you got this expression. So plus r, what you will get? Obviously, you will get r divided by 2l plus or minus square root of, this is already squared, right? R divided by 2l, so பிரச்சனை இல்லை, 1 by s. So similarly, if we will find omega h, then you will get this expression. Okay, I'm looking for bandwidth. So omega h minus omega L. What it is? Omega h equal to R divided by 2L plus or minus square root of R by 2L the square plus 1 by LC minus omega L. Omega L is minus R divided by 2L plus or minus R divided by 2L the whole squared, okay, plus 1 by LC. Here the plus or minus இருக்குல்ல, you want to consider plus alone for frequency. Consider, because there is no negative frequency under, okay, consider positive for frequency. So what you will get? So obviously you want to replace this by plus alone, okay, only plus. So here also only plus. Okay, this is my plus actually. Okay, consider only plus. This minus and this minus becomes plus, right? So now actually this is minus of these things, right? So now what will happen? R divided by plus, this is my omega h plus 1 by LC, minus of this minus becomes plus R divided by 2L. This minus and this plus becomes minus square root of R divided by 2L the whole square plus 1 by LC. Now what will happen? This plus, this is minus. Okay. So simply you will end up with R divided by 2L, again R divided by 2L. It becomes 2R divided by 2L. This is my omega h minus omega L. So 2 to get cancelled. This is L, right? 2 to get cancelled. So this is, R by L omega h minus omega L in terms of radian per second. So this is the bandwidth in terms of radian per second. Okay, but omega h equal to 2 pi f. So omega h equal to 2 pi fh, omega L, so 2 pi fl equals R by L. Take 2 pi as constant. So this is fh minus fl equals R by L. Okay, I'm looking for fh minus fl. Actually, that is my required bandwidth in terms of hertz equals R divided by 2 pi L in terms of hertz. Okay, so these two formulas are very important. Bandwidth in terms of hertz, in terms of radian per second. This is the way to derive. I hope so you enjoyed this derivation. Okay, I will forward my material. In that everything is available. Okay, so time being, take this and I will. So this is the bandwidth. So I hope so you got the idea what is bandwidth, how to calculate bandwidth. The formula for bandwidth, it is very important. The next you want to know one more interesting relation between omega h, omega L, and one more omega, resonance frequency. What is the relation between these three things? Very, very important relation. If you will derive this relation, you will get omega r squared equals product of omega L and omega h. That's quite interesting. That we will derive. Huh? Am I fast? Fast ஆ போறேனா? ஒரு 10 days கழிச்சு நவம்பர் 2ஆம் தேதி தான் கிளாஸ் ஸ்டார்ட் பண்ணுவேன். சர்க்யூட் தியரியை மறந்துடாத. சர்க்யூட் தியரியை மறப்பேன் இல்லைன்னு தெரியாது. வாழ்த்துறையை மறந்துடாத, சரியா? So now take equation number 2. What is my equation number 2? What it says? Equation number 2 and equation number 3. Okay. Can I take these two to derive that relation? Copy. Okay, I'm pasting it here. Okay. From equation 2, what is my R? Can I write R equals 1 divided by C omega L minus L omega L? Take equation number some 2.1. Okay. Now, equation number 2.1 is equal to equation number 3, right? Since this is also R and this is also R, equate these two. What you will get? This R is 1 by C omega L minus 1 divided by minus L omega L equals this R L omega H, equation number 3. L omega H minus 1 divided by C omega H. Okay. So now bring all L to one side and all C to another side. This is my L omega H. Bring this minus L omega H to the right hand side. It becomes plus L omega L. Here I am having 1 by C omega L. Now bring this minus 1 by C omega L to the left hand side. It becomes 1 divided by C omega H. So now take L as common. Here it is omega H plus omega L. Here 1 by C is common. So this is 1 by omega L plus 1 by omega H. Take the LCM here. It becomes omega L omega H. Omega L plus omega H equals L times omega L plus omega H. Now what is this? Omega L plus omega H. Omega L plus omega H both are cancelled. So above equation can be written omega L omega H equals 1 divided by LC. Can I write? Very புரிஞ்சா? You know from the basics, okay? What is my resonance frequency? You know, XL equal to XC. When XL equal to XC, resonance occurs. XL equal to L omega, XC equal to 1 by C omega. Therefore, omega squared equal to actually 1 by LC, right? So this is resonance frequency. So omega R squared, right? So now what is this 1 by LC? What is this 1 by LC? It is omega R squared, right? Therefore, omega R squared equals omega L, omega L. This is the relation I have given, right? Omega R squared equals omega L, omega L. I derived the same thing, right? It's very, very important relation. The relation between highest and lowest and resonance frequency. Relation between highest, lowest and resonance frequencies. Hey, are you with me or not? No more voices.
Yes, sir.
Simple mathematics, right? I hope so you are enjoying. So this is about the bandwidth. So bandwidth, how to calculate bandwidth, and what is the relation between resonance frequency and this omega L and omega H. Okay. So now what is the next interesting factor? It is called quality factor Q. Okay, this one alone we will complete. So what is quality factor? And as I told you earlier, you know what is the beauty of the series RLC circuit? Series RLC nale first mind la vara vendiyadhu resonance. It's very important. Okay, it's having a lot of application. Second, நான் சொன்னேன் இல்லையா, the voltage drop across inductor or voltage drop across capacitor, it is greater than the applied voltage. Can you remember this? சட்டியில் இருக்கிறதா ஆப்பைக்கு வரும், பட் இங்க வராது, அதிகமா வரும்னு சொன்னாங்களே. அப்பா 8 அடி பஞ்சா புள்ள 16 அடி பாயும். You know why? That is the quality of their parents, right? Because of the quality of the parents and you know children are doing well. Just okay to understand. வேற யாரும் எதை மீன் பண்ணல. So similarly here also the quality factor it is defined, you know. Here also VC is very greater than V. Okay. So here quality factor is defined. Okay. The ratio between either the voltage drop across inductor to applied voltage or the voltage drop across capacitor to applied voltage. Now see the beauty. Now what is the voltage drop across inductor, which is equal to Q times V, or across capacitor, which is Q times V, where V is the applied voltage, right? If Q is greater than 1, what will happen? VL is greater than V, right? See my observation. If quality factor is greater than 1, then VL is greater than V. Similarly, here VC is greater than V. So that's what this quality factor should be very, very high for a RLC circuit in order to satisfy all these things. And it is the figure of merit. Okay. By seeing the why is it so called quality factor? Got the idea? If Q is some 100, okay, then what is the voltage drop across inductor? It is 100 times applied voltage. Okay. Electronics people, they will study about amplifier. அதை பத்தி பேச நிறைய பேசலாம். பட் ஹியர் ஐ டிடன்ட் கோ ஃபார் எனி ஆம்பிளிஃபிகேஷன். நான் எதுவுமே ஆம்பிளிஃபை பண்ணல. பட் ஆம்பிளிஃபை பண்ணாலும் எனக்கு என்ன கிடைக்குது? அவுட்புட் வோல்டேஜ் வந்து இன்புட் வோல்டேஜோட 100 டைம்ஸ் மல்டிப்ளை கிடைக்குது பை சீயிங் திஸ் சிம்பிள் ஃபேக்டர், குவாலிட்டி ஃபேக்டர், ரைட்? That's what it is called, quality factor. And here this formula is very important. It is the ratio between either voltage drop across inductor to applied voltage or voltage drop across capacitor to applied voltage. Okay. So what is my Q? Therefore Q equals, what is the voltage drop across inductor? V equal to I times R. So where I, and R is impedance. What is the impedance offered by the reactance offered by the inductor? J times XL, where XL equal to L omega. You know, V equal to I times R. What is the voltage drop across inductor? Series circuit. So I is same. What is the impedance offered? This is XL. So I times XL equal to J L omega. Okay, this is at resonant frequency. So it becomes J L omega R divided by what is this V value? V equal to I times R. Okay, applied voltage at resonance. You know, at resonance XL, XC both will be cancelled. So all the voltage drop across resistance, right? So you will get I times R. Now, okay, so take the magnitude alone. Take the magnitude, you will get L omega R by R. This is the formula, one formula for quality factor R. Coming to this formula, VC here, this formula. What is the voltage drop across capacitor? Here also V equal to I times R, no change. At resonance, all the voltage must appear across resistance. How will you write the formula for voltage across capacitor? Here also same current I, but this time this is XC. So XC equal to 1 by C omega. So this is I divided by C omega R. So I divided by C omega R. So now both I will be cancelled. So you will end up with 1 divided by C omega R, right? Resonant frequency. So 1 divided by RC omega R. This is the another formula for quality factor. But in terms of RLC, the formula for quality factor is, okay, 1 by R square root of L by C. Here you got two formula. This is one formula in terms of inductance and resonant frequency. Here another formula. If you know capacitance, then you can use this formula. Okay. If you know everything, then you can use this formula. How this formula came, it's quite interesting. You know Q equals, this is L by R. What is omega R? What is omega R from this relation? Omega R, you know, 1 by square root of LC, right? So now substitute here. Omega R, 1 by square root of LC. Now this is 1 by R. Bring this L, okay, inside a square root. You will get square root of, when it goes to, okay, inside square root, it becomes L square divided by LC. So here square and the L becomes cancelled. So 1 by R square root of L by C. This is my quality factor. What is the unit for quality factor? Anyone? What is the unit for quality factor? Any guess? From this definition?
No unit, sir.
No unit because both are voltage. Yeah, very good. Thank you. So this is my quality factor in terms of RLC. Okay. So here also the beauty is, now take this formula. Here also it becomes 1 by RC and 1 divided by, what is my omega R? It becomes 1 by square root to LC. So it becomes square root of LC divided by RC. Okay, keep 1 by R as it is. Now move this 1 by C, okay, inside square root. It becomes, so square root LC. So divide by C square. So now these two will be cancelled. So you will end up with again the same formula, 1 by R square root of L by C. This is my quality factor. Another formula. So three formulas for quality factor. Okay. This is formula number 1 in terms of resonant frequency and L. Here in terms of resonant frequency and C. Here no need of resonant frequency. Once if you know RLC, then you can use this formula. Okay. So based on the given things, take any formula, but please make a note. It's very important. All the formulas. Okay. My final topic. It's quite interesting. Relation between quality factor and bandwidth. very important concept. Relation between இந்த நீங்க தானே மெக்கானிக்கல் ஃபைனல் இயர் அந்த வாட் இஸ் தட் இந்த மாஸ் ரோவர்லாம் டிசைன் பண்ணுவீங்கல்ல அது யாராவது இருக்கியா நம்ம இதுல சர்க்கியூட்ல அங்கெல்லாம் சர்க்கியூட்ல அந்த கான்செப்ட் யூஸ் ஆகுமே anyone is there from that team relation between
ராகுல் கிருஷ்ணா இருக்கா சார்
ஓ அவருக்கு இப்போ இந்த கான்செப்ட் நிறைய யூஸ் ஆகும்பா relation between quality factor and bandwidth quality factor and bandwidth any guess at least without deriving if quality factor increases what will happen to bandwidth bandwidth decreases both are inversely proportional to each other இந்த கம்யூனிகேஷன் பாயிண்ட் ஆஃப் வியூல நிறைய இன்ட்ரெஸ்டிங்கா பேசலாம் ஓகே பட் மெக்கானிக்கல் பீப்புள் அகைன் அதனால தான் யோசிக்கிறேன் பட் ஜஸ்ட் ஒன் லைன்ல முடிச்சுட்டேன் இஃப் யூ வில் இன்க்ரீஸ் த குவாலிட்டி ஃபேக்டர் பேண்ட் வித் கம்மியாகும் எப்பவுமே த ரேஞ்ச் ஆஃப் ஃப்ரீக்வன்சி சுட் பி லோ ரைட் அதனால தான் எஃப்எம்க்கு என்ன பண்ணாங்க தெரியுமா 88 மெகா ஹெட்ஸ் டு 108 மெகா ஹெட்ஸ் லிமிட் பண்ணதுக்கு ரீசனே அதுதான் சப்போஸ் ஜஸ்ட் அசியூம் எனக்கு வந்துட்டு ஒரு 1 மெகா ஹெட்ஸ் டு ஒரு 1000 மெகா ஹெட்ஸ் கொடுத்தேன்னா ஓகே அசியூம் யுவர் எஃப்எம் ஹார்ட்வேர் யூ வாண்ட் டு டியூன் இட் ரைட் அப்போ நீ என்ன பண்ணணும் ஒரு சேனல் தேடுறதுக்கு 1 to 1000 மெகாஹெர்ட்ஸ் வரைக்கும் போய்கிட்டே இருக்கணும் பட் இஃப் த ரேஞ்ச் இஸ் லோ then it is easy for you people right so always the bandwidth should be very low as possible that is the best practice in communication point of view so quality factor high அப்படின்னா என்ன அர்த்தம் bandwidth கம்மியா இருக்கு அப்படின்னா quality factor அவரோட குவாலிட்டி வந்து அதிகம்னு அர்த்தம் okay see for FM the range is low so easily you can go for any channel within a second or within a minute okay so obviously the quality is high right so quality factor and bandwidth always both are inversely proportional to each other it's very simple take this equation number first formula for quality factor Q equal to L omega R by R right so I want to take this Q it is L omega R by R what is this can I write bring this L to the denominator what you will get it becomes R by L Q right now what is omega R it is 2 pi FR right this is R by L now bring this 2 pi to the denominator it becomes FR divided by R divided by 2 pi L can I write like this now what is this any guess this is FR divided by what is this R divided by 2 pi L who is this guy
bandwidth
so it's another important relation okay so quality factor and bandwidth both are inversely proportional to each other so quality factor which is equal to resonant frequency divided by bandwidth okay அதனால தான் சில பேர் என்ன சொல்லுவாங்கன்னா the ratio between resonant frequency to bandwidth this is your quality factor அப்படிம்பாங்க but the original definition even நான் கொடுத்ததே ஒரிஜினல் டெஃபினிஷன்லாம் கிடையாது நான் சொன்னேன்ல இங்க Q இது வந்து ஒன் பாயிண்ட் ஆஃப் வியூல எக்ஸ்பிளைன் பண்ணுங்க இந்த மாதிரி எக்ஸ்பிளைன் பண்ணேன் ஒரிஜினல் டெஃபினிஷன் இஸ் டிஃப்ரெண்ட் தட் ஐ வில் எக்ஸ்பிளைன் இன் த நெக்ஸ்ட் கிளாஸ் பட் குவாலிட்டி ஃபேக்டரே நிறைய ஃபார்மட்ல டிஃபைன் பண்ணலாம் ஓகே தட் இஸ் த பியூட்டி ஆஃப் திஸ் குவாலிட்டி ஃபேக்டர் ஸோ அக்கார்டிங் டு மீ திஸ் த ரிலேஷன் பிட்வீன் குவாலிட்டி ஃபேக்டர் அண்ட் பேண்ட்வித் ஸோ போத் ஆர் இன்வெர்ஸ்லி ப்ரொபோர்ஷனல் பேஸ்ட் ஆன் திஸ் ஃபார்முலா numerical problem may be asked okay so that's it for today's class I hope so you enjoyed all the concepts right for today's class and I will summarize the same okay by November 2 okay so thank you thanks for your attention that's it for today's class any doubts okay you may stay so others you may leave so happy holidays okay enjoy at your home வீட்டில் இருந்துக்கிட்டே ஹாலிடேஸ் கேட்குறோம் பார்த்தியா தேங்க்யூ தேங்க்ஸ் ஃபார் யுவர் அட்டென்ஷன்